Hi, everybody.
Действительно, давайте немножко поговорим про
Yes, let's talk a little bit about the distributed firewall. I don't know how familiar you are with the subject. It's quite new. It's hyped right now. Okay. So what are we going to talk about? Okay. The problems, so why we're doing this, a few words about the network landscape. It's not everywhere, and eBPF is not needed everywhere. How we do that, the network access management, implementation features, and then plans on the results, right? Okay, so my name is Igor Panarin. I've been in IT for many years. I was a developer in foreign companies for many years, so now I'm here. Okay, and I'm there in the infrastructure department. I work on the firewalls. So which is the problem that we're trying to solve? What is it? The network landscape is how, in most companies, it looks. Usually the network is split into different segments. The traffic is filtered at the junctions of segments at the firewalls. So if you look at the network description here, there are lots of rules, and the configuration size on devices is limited by the vendors himself. In other words, firewall is not made of rubber, and even if we have different segments, this starts to be felt. We also understand the traffic flows between two segments, and when it goes there, so any change of the firewall configuration has the potential impact on all traffic. So as soon as we change something, the connection between the segments is lost. So a decision like this is scalable theoretically, right? We can hire additional people, we can introduce additional firewalls, we can change the network, but this is not realistic, so scaling is not an option here. And finally, we'll talk about the security. Yes, we split the network into the segment, and there is very little filtration for one specific segment, but security people say, no, you'll have to filter. Okay. This solution does not give us possibility to filter within one segment. We either have to split the network further or do something else. Okay, so the host-based firewall is here, like Chip and Dale will help us. Let's see what it can do. Okay, so it will introduce granular points of filtering and monitoring. So on the host, we have an agent. It filters the traffic, and by doing this, we can take away the filter between the segments. So potentially, we can delete the firewall. So the configuration on such firewalls is not voluminous. It only controls the traffic that comes on this host. From the point of view of application, previously we were impacting the whole traffic, but when we change the configuration, we only impact the traffic on the filtering point and on the specific host, so we can apply it in the moment, if you will. And then the solution is potentially scalable. So if we choose to add a segment or a host, it's enough to include it in the firewall and it will work. And there is filtration with one segment, so our security personnel is happy. So where to start? Let's think about that. There's not that many people, but which of you know what host-based firewall is? Who is familiar with granular filtration? How many people tried to introduce that? Okay. Who will say that this is easy? Okay, well, let's talk later on. Okay, so let's look as an idea, what does it start with? Let's say we have a control plane, we have a host. At the host, there is an agent which configures the filtration, eBPF, for instance, BPF, which is very popular right now. So it looks quite logical, right? So let's use the implementation plan. Let's take an open source decision. Let's have an adapter. Let's check it. Okay, it's introduced, and that's it. It looks like it, right? So you can go ahead and implement it, right? You probably don't need me, but let's look at the reality. This was the idea. This is how we started. So where should we go? Okay, so we decided to introduce the eBPF agent in order not to use our own resources. Let's look at the market. The market doesn't offer a lot of solutions like that. They exist, you can try to use them, but even if we try to take these solutions from a third party, and we had some experiments like that, it's very hard to maintain the system. It's very hard to make any changes into the system. It's all subject to contract. Can we do that? Yes, but from our point of view, personally, it's not doable. Any host of the company will have an eBPF agent that somebody else produced, and if there is a minimal bug, this bug will spread into the whole company. This looks potentially very, very bad. Let's look at some ready decision. Okay, let's look at Cilium. Let's look at the part, to take the part of Cilium that we could use. Actually, this is tied to Cilium. We looked at several companies, tried to do it ourselves, tried to cut it out. No, it's not possible. There's just too much there. Theoretically, can we go there? Yes. Can we later on monitor it and expand it? Theoretically, yes. Practically, no. So if you think about it, we don't need much from that Cilium. We only need filtration. So let's look at the third way. If we take our own product, so we put together a team. We have some experience with BPF in the company, which is a plus. If we use Go Linux, Drapi, SPIFFE, then it looks very realistic. And this is where we went. This was last year. This is how it started. What do we want from eBPF? Okay. So we want the solution to filter incoming and outgoing traffic. We want the quick policy applications in minutes, if not seconds, and there should be a single point of management, an active agent. And of course, we only open what is needed and where it is needed. As I said before, the task kind of came from the cybersec department, and this is how we dealt with this. How to manage network access? Okay, a few words about that. We have to filter incoming and outgoing traffic. This process can be split into 5 simple components: a request interface, the access description, this is the truth for us, which should be open, some kind of control plane that transfers it from input to the desired result, a data plane, and the devices. So let's look at this at each stage of that. How is access, network access described? Okay, so we have some external rather processes. There are a lot of interfaces where you can use in order to access the network, and this is how it's described. There is a set of server. They need access to other servers according to specific protocol. If we talk about a distributed service, then we use that. Does it work on host-based firewalls? Yes, it does. So we will then manage a group that has eBPFs and BPFs inside. So On the first glance, at the first glance, it looks okay. If we look at our interface, this is how it looks. As an owner of this service or server, this is what I can say. This is my group of hosts, and this is what their description. Then how can we describe this network access as ingress and egress, in and out? So this serves the eBPF purposes really well. So we have the ingress list of accesses on some protocols and some hosts.
Таким образом, вот если вернуться посмотреть, управление именно входящим трафиком покрыли.
Managing incoming and outgoing traffic is covered. So let's look at the control plane. How do we prepare the accesses? It's not the first time that I talk about that, so I'll go very quickly. We have some kind of targeted condition. So we'll look at this, we'll look at the configuration, we'll look at the difference. This difference goes into the data plane. The data plane figures out whether it's useful or not. We take the new configuration and take the status, which we put back into the description of access. But there is one very important nuance. When I referred to kind of iron firewalls, I mentioned that they are on the junctions of different segments, so we can't use them often. In some cases, we only use them at night. So we have to count minutes, if not seconds here. So the computation that I was just describing doesn't do the job, because we take the state of everything that has to be open, and then we take the state of everything that we have on the firewalls. We calculate the difference, the delta. So if you compute all of this, it will take hours. So what can we do here? Well, the application side, right? Well, nothing new here. We see an open source. We see a change in the source, and therefore we have to respond to that change. The change has to be minimal as possible. If somebody added on a new port, a new protocol, that's the scale of it. And then we'll have to compare it with the cache in the configuration and getting the delta. The configuration cache has to be topical, right? Present time. This is one of the most important conditions. And it works in the reverse direction as well. If there is a change in the data plane, we have to figure out very quickly in the cache. So when we add these flows, in our case, we kind of rewrote the engine which was responsible for the computing.
Собственно, вот на отладку этого уходит достаточно большое количество времени. Это действительно новый подход.
It takes a long time to figure all this out, but this is the right approach.
Версионирования как такового нет, но кажется, мы к нему так или иначе придем. Тем не менее, вот с точки зрения ХБФ, да, доступы могут.
From the point of view of the eBPF, we have good enough speed. Let's look at the data plane for a little while. The data plane which will manage the devices. So what is data plane? In case of the eBPF, it's another control plane on a smaller scale. So basically, it has to accept all the changes that came from above. Okay, there is a policy thinker inside. So it has to have an engine which prepares these changes. It has to have the desired state, store it, compare it to the condition that we have right now, and to prepare the change so that the agent would pick it up. So the agent has to be active, right? So we don't give it the information the other way around. It has to give the information to us and tell us about the state. As a result, we have a data plane which has a control plane inside. A few words about the HBF access, about what we have, what kind of rules we have. I'm not going to tell you anything new. It's about the rules and the way they're organized on firewalls. The most important of this is the blacklist. Let's imagine we have a big network, a lot of hosts, and all of a sudden, one of the hosts is infected.
And so you also have to see what rules exist on others, and this is why you have the blacklist. Then there are also the align rules and the deny all. That is, everything is prohibited by default. And this is what it looks like on the host. So this is the type, inbound, outbound, ingress, egress, allow, deny, CIDR, and port protocol. To prepare a rule like that, if you remember in the control plane, first we have the rule as the group to group, service to service, then we have to open it in the particular list and then open it up again so that it opens for HBF, where we manage it just through CIDR. So the HBF doesn't know anything about the levels above. We have the active agent and the active point. And now let's see the devices. Let's go back to the overall scheme. And last time I just showed the access design firewall. You have the internal firewall, the border firewall, and most of the time they are different vectors and different interfaces, and all of this has to be serviced. And in terms of the firewall, this is what we are doing. From each firewall, we are taking the table, and we understand where we need to open what, and we use this access design firewall. This works for the hard firewalls. And what is a host in terms of a distributed firewall? Let's have a look at the notion of a host. We have some hardware in a company, and probably there might be Linux or Windows, and we will support Linux. So Windows is still in the gray area. We'll see that we, but hypothetically, we can support Windows as well. Linux can have Linux and Windows and other virtual tools. But most importantly, we have the golden image that can be built by the agent. And when we install something virtual, the agent will be there. And so we can cover a large fleet of machines. It looks convenient, and the task is to cover everything. And for our agent to be active and the control place to talk to it, we need to identify that it is the right host. If it was just an IP one, then it's this is super reliable. Anyways, we are going around a certain idea. We should have the imprint of a host, the trace of a host that is can not be faked. So we want to get some print from this virtual network, and we can use this imprint as a check. And HBF then is operated by specific hosts rather than IPs. And what this results in the description of the access, when we described the existing system, we had to add another another thing, we are using the new thing. This is the link to this host, and the rules prepared by the control plane will look this way. We will have at the beginning the host and then the rules that we already know. And in the UI, it looks like this. We have the list of the exact IPs, the hardware, the hard firewalls, and the list of host firewalls. And this is the access design. We could have forgotten about the hardware firewalls, but we live in the real world, and so we have to take into account the HBF and the hardware domain, and we have traffic at both. What do you need to open the traffic at HBF? This is what the inspection could look like. This is the ongoing inspection on the hard firewalls, and it goes through the new point. We would like to see that. And to open it on a hardware firewall, it's not enough to have the reference of this host. I need to go the IP, and from the control plane, I have the back resolution, and I will use it for the for the hardware firewalls, and this is also relying on the data plane, and so the access can be provided quite fast on the hardware firewall. But can you open up everything if the user asks for something and they want it? So can you take it to the control plane? Obviously, not everything should be allowed for opening. Should you check everything for approvals? In our company, we have 600,000 rules on the firewalls. If we check that manually, this is an infinite amount of work. There is a server or a service that does that automatically. This is how it works in a very simple way. There is the validation source, validation service and approvals, and there is the access description, the access design control plane, and routing criticality, and you can write that into rules. If there is an IP from a certain network, then it is this and that, and if it is a test and prod, then definitely you don't provide the access. We also need to know certain information about the criticality, and the validation and approval services stores optimized rules for fast answers. Who requires approval, who doesn't require that. And since in HBFs we have the reference to a host, here we need a resolution. We need to introduce new parameters, so you can open this for certain hosts, so that our system could say this is the IP for a certain host, and to a certain degree we have to rewrite the system that is doing the validation and approvals. You cannot launch HBF without that, so we filter incoming and outgoing traffic. We have a quick policy application, and we have the single point of management activation, and we open what is needed and where it is needed, and it looks like we can launch. But let's look at the nuances. Remember the rule deny all. We have a host, it is deployed, and it is deny all by default. It means that you cannot enter it. We have this host, and no one can enter there. There is no monitoring or anything. It is complicated to work there. and you cannot even check, not even install the software. So you need some preset rules, and we have a lot of hosts. The idea that we came up with is what about having certain templated access rules? So let's say that when describing a service, you can immediately specify templated access, and all the hosts that exist on the virtual machines, they initially have access to logs and metrics. And by doing this, in the description, apart from ingress and egress, we also have the templates that are key for the work of the infrastructure. And so everything that we go from describing the service top down, we have 4 steps, and then we have to change it to group, point to point, and then only will it go to HBF. It looks great. We have that in place. Is there anything else that we should take into account? The impact on traffic. We launched the agent, and what if this negatively impacts the traffic? Right now it works, but if there is an impact, it will look bad, and we are just launching. And so what could we come up with? First of all, the testing of BPF, you can see that it doesn't influence a lot on the traffic. There is no magic as to how you launch to operate, and you select, for example, the database, and you introduce the HBF, and everything went down. So it's not a good thing to happen. A simple solution, the auditing mode. We write rules, but they do not filter anything. They just log the events, they register the events. This is something to be filtered off or not. And so we understand how it would work to launch it and then to manage it. Once again, the agent is active, and we have no access to it. You cannot go to the server and change something. It should be completely autonomous, so you should change it somehow, and it works the same way we operate with a control plane. We should have the right footprint, and we need an external service from where we can get this image, and then operate in the audit mode, and then launch in a full-fledged operational mode. And HBF can update itself, and we have the mode for launching into operation, and then you launch it. But to understand if we have access, we need some visibility and an analysis and inspection of access externally. It looks like a query in terms of the hardware firewalls. It is installed, and in HBF the function is also done, and we've got to understand the filters, and you have to check it both on HBF, FW devices, and you need to do the configuration caching and the telemetry so that you could see the traffic. In case of the HBF, to a certain extent, we are lucky because first and foremost, we have this thing that keeps the logs and collects them fast, and the storage of logs is already there. On top of that, we just have to add the control plane. As to HBF side, we have to write the logs there, and we can have something similar to contract on the host, and the default one didn't work for them. They did one in-house, but you can see the traffic via this host. It aggregates the data and takes it to the log storage. And there is also an inspection. There is the system that can use the IP for the host, see the port, see all the events and the traffic. Cool. We have analytics and telemetry. And one more thing is operation itself. We are completely replacing the system of filtering in the company. We still have the hardware firewalls. So we have the host, we have the border firewall and the HBF. Anything can go wrong at any point. What it looked before, as a user, I asked for an access, something went wrong. I didn't know where to go around this. There is a good system organized. There is an entry point. For example, this is the access, the team for managing automation of access, and they also have the infrastructure security there. If this happened at HBF, then the development of HBF steps in, or the network engineers. It works end to end. Every team has an SLA, and they have a complete SLA. So it is ready for operation. And to work with this and to support this, you need to do a lot of work. If you only have the hardware firewalls, then a couple of points could be removed from here, and you don't need the end-to-end process. The more points you have, the more wish you have to unify it somehow, streamline it. Okay, now we covered even the operations. And last but not least is the user experience. I spoke about the control plane, the registration of the host in the inventory post-reference, and the other way around, the IP. And for the user, when they have something virtual covered by the HBF, they want to do it in one click. In our case, it looks like this. There is a generic interface where you can use another machine, hardware with the usable workload, and also managing the access. This is the single interface. And so when you create a virtual machine, here you can work on that, and then you get the control plane that lives inside, and then it registers this host here.
It also registers this host in the access description system, so it also serves another role. So basically, you click just one button when you added the virtual one, and then now when you want to manage it, it's all done in one click. It reads the data plane in the sense which policies it has to use. Okay, so what do we have? User comfort. We also took this into account. So this was a long way, a very long path. What else would I like to tell about the details of HBF filtering implementation, the policies? It looks like there is nothing really very difficult, but actually the designers wrote their own engine. We can talk about it in the corner, so to speak. I wanted to tell you about the internal logging and stability of HBF agent, because they can be dropping as well, and how to collect the logs. And finally, in order to employ this, we needed to test it. So the guys created their own test environment. They They created their own testing universe. Okay, so where are we now? Okay, this is the reality. We have a VP that is closer to prod. We have the agent. There are hosts that are embedded into the golden image. There is filtering of ongoing and incoming traffic. There is an agent, it's updating. We collect metrics and logs. We're covering a large test segment right now that is not connected to prod directly. So where the production is working, such as billing and data processing, so far we're not there. We have to prove to the guys that it is safe. Finally, the support has been organized. Interesting that one might think that you need a lot of people, a lot of engineers for that. But from the point of view of network access control or management, you only need about 3 or 4 people in a team. Yeah. And infrastructure department, 2 more people. So basically, we had only 12 people that were doing this job. So let me tell you a little bit about our plans. Of course, we want to increase the coverage and not only cover the virtual machines. We want to go to the bare metal, the Windows, and if we're talking about the metal hosts, we want to integration with that. Since this is our own creation, we do not rely on anybody else. And we want to have not only L3 coverage, but to go higher. When? I don't know. In the future. We also look into the VPN. We'll see what will happen. So the results. Okay. So let's go back to the first picture, the network landscape. We cannot realistically take away firewall between, or rather among the segments. But right now, in the moment, so to speak, the configuration on firewalls decreases. So that takes away a huge number of rules. In the eBPF segment, we have fast application of rules within seconds. Of course, we say in minutes. We are actively increasing coverage. I told you that we've been doing this, and also we are fulfilling the requirement that InfoSec people wanted from us. We have filtration within one segment. Lessons learned. What lessons have we learned? If we are doing HBF, let's think about it, right? We want to introduce the distributed firewall. It's not about just developing an agent. It is a large part of it, but it's the only thing. And you will never be able to cover it all by introducing a new adapter. There are lots of phases. All of these phases have to be reconsidered and changed. Implementation and operation in advance is very important. I'm talking about obvious things, but I think our experience is worth something. You will benefit from it. It is important to study the network landscape. It's one thing to say that we'll do away with the firewall, but in reality, it's not always possible. And HBF is not always the solution of the moment. And of course, it's important to integrate information security processes from the beginning of the development. So if you don't automate it from the point of view of approval, it won't be possible to launch. And a typical question, yes, this is an internal development, so we cannot share the code with you right now, but we're ready to share our experience and approach. Thank you very much for your attention. If you have any questions, I'll be happy to answer them.
Подходите, пожалуйста, к микрофону.
Yes, please use the mic when you're asking a question. Hi, my name is Ilya Cherepanov. I work in the RBB. Have you ever dealt with fail safety? Fail safety. There are a lot of agents, a lot of eBPF agents. So what if something happened? There is a glitch, and all the agents go back to re-register. What will happen to the control plane? Will it not drop? Well, the control plane is also distributed. It's in all cells, so I won't be able to give you any details right now. I can address you to our developer. Yeah, but yeah, we take this into account. It is fail-safe. Thank you. My name is Nikita. I have several questions. Please stop me one by one. Question number one. What is your policy? You have this services concept. So what is it? Is it the host-based firewalls? What is the source in this particular case? You mean the policies in the agents, right? In the data plane, or policy the way the user see it? Okay, let's start with the policy the way the user sees it. Well, the user says, okay, I have a service, I have a group of hosts or a group of IT people, and I've described SRC as this thing. Okay, so the source has ingress and egress. So this is how it looks for the user. If you go down to the data plane, to the host base, the host which has the host-based firewalling, again, there are ingress-egress rules, and they have the rules of where to go, when they can go and they cannot. The user doesn't know anything about it. Yes, but if we talk about the groups on the control plane level, there should be some correlation. If I look for an access from the service A to the service B, if the B service goes FQDN, do you have any types of object that you can request access to? Well, FQCN is an external address. For our purposes, it's an external address, and that's how it is prescribed. You're only engaging your own data centers, right? Right now. Once again. Okay, so the perimeter of the service of the data center, you have not studied that. Right. So the VPN story is still has a question mark, and I don't want to say anything about that. Okay, so right now the service integration is within the DCs. And how do you maintain the lookups? How is it filled? How is it supported? And if the network is changed, let's say one point's IP address is changed, endpoint is changed, is it automated? Is it reflected? Is it controlled? Well, there are new data centers which are completely automated. Okay, so there is hardware, but there is also a platform which configures the hardware, and we can look up absolutely everything, all the setting, all automated parts. So by going in there, we'll have a full picture of a specific host. The group, it is registered, and we see the details that are coming from that platform. This is how it looked in the new data center. The old data center, which didn't have that, all this info had to be put in manually. So I have an extra set of IP addresses. If everything changes, you have to do it manually. If there is disaster, you have to address it manually. So people who are doing the services, who are they? The owners. The interface which I showed you has two types of users. One of them need access, but they don't really control how the reality is implemented into the service. And the second type are the people who are responsible for the service, responsible for the hardware. So they know the IP addresses. let's say this is the system which collects metrics. So we can horizontally scale it, we can fill it with the content, and the users which request access to it don't have anything to do with it. What if I have two services? What if I have more services on each host? This is a great question. Thank you. Yes, but at the moment, we have a rule. We basically had to rethink everything. The system doesn't cover the whole company at the moment, but whatever is covered, we think that one host, one service, one owner is the best equation. One database which is not depending on the billing, and then there is a service that collects data from the clients. No, we should not have it like this. Thank you. This is a super question. Right. We also have some know-how, and I will be happy to talk to you outside. And the final question, how do you do the agent provisioning and the policy validation? How do you make sure that the policy has not been neglected? If there should be no admins on host, but if this is not an admin, if it's a virus or something else, malware. Okay, so there is a host, the host has its print. So the host guarantees that it's what it is. And if something happens on it, let's say a user doesn't have access to root. But let's say somebody has access to root, it came in and it killed the agent. So if the agent is reporting that the change of the rules happened, then the control plane understands that this host behaves strangely, and the blacklist story kicks in. All right, so we have to isolate that host, and we have to look deeper.
So the agent opens that, yes, and if the control plane understands that they don't get the right. What if I kill an agent? Like, can you kill an agent? Yes, we see that there should be an agent. It's not there, and something strange is happening there. And what if there is some plant work and I have to decommission it for some time? Where is this borderline where the disappearance of an agent becomes a problem? This is about the operations. The incident will be registered. We'll see that it is an incident, and we'll respond to it differently. And the integration should be there. And right now, no. But this is a good topic to consider. Let's stop at that. I would be happy to talk to you afterwards. Sure. Any further questions? It looks like we do not have any. Igor, thank you very much. Select the best question. The one that I really liked, this one. It was a good question. Okay. Can we ask you to come over?
Друзья, спасибо.
Thank you, friends.